Hi, I'm Bram Decimet with Flanders Scientific, and in this video we're going to take a preliminary look at LightIllusion's ColourSpace to calibrate one of our DM series monitors. I've opened ColourSpace to start, and we're going to click on this profiling option button to connect our equipment. First we'll connect our test pattern generator, and in this example I'll be using DaVinci Resolve. So to connect to Resolve, I'll select Network Server from the Hardware drop-down list and then press Connect. When I do this, I'll see a local IP address populate here on the right. I'll take note of this IP address and then go to Resolve to establish the connection. From Resolve, I'll want to ensure that I have some media on my timeline and that my selected signal range matches the signal range being used on the monitor. In this case, we'll be using video range. Next, I want to select the Color tab in Resolve, then click on Workspace, then Monitor Calibration, then I'll select LightIllusion or LightSpace from this menu option. At this point, we'll be prompted for an IP address and we will enter the IP address we noted earlier in ColourSpace. Then we'll press Connect. It is important that you do not close this dialog window within Resolve, as that will terminate your connection. Next, we'll come back to ColourSpace, and in this Calibration Patches dropdown, we will want to select Automatic so that ColourSpace can automatically send test patches to Resolve. We can verify that we have a successful connection by going to the Manual Measure window and moving the sliders to generate a test patch through Resolve to our connected monitor. Next, we'll click on the Probe Options button to connect to our probe. In this case, we'll be using a Colorimetry Research CR100, so we want to select that from the drop-down. Select Rescan to find the COM port, then press Connect to connect to the probe. Once connected, I'll make sure I have the correct probe matrix selected on the probe. So here we'll select DM240 as that is what we will be calibrating. Then, ensuring we are still displaying a bright test patch on screen and the probe is centered on the screen, we want to click on Probe Calibration to establish sync between the CR100 and the display. Once complete, we'll go to the monitor and from the Color Management menu ensure all settings are default with the exception of the Bypass LUT option. We want to change this from None to 3D. This will bypass the current 3D calibration LUT that is active, allowing for native wide gamut profiling of the display. Once that is complete, we can return to ColourSpace and click on the Display Characterization button. From this window, we can select the type of profile we want to do. If you are short on time, we suggest using the Gray Only or Gray Only Large options, which incidentally will work very well on the DM240 as it is a very linear display. If you want to perform a longer display characterization, select Cube and then your desired profiling size. We would suggest either 17 or 21 for optimal results if doing larger characterizations. Again though, we'll be calibrating for a simple target, Rec 709, and the display is very linear in its behavior, so we'll start by just doing a simple gray-only profile. Once we've selected this, we can press Start and the profiling process will begin with ColourSpace sending test patch values to Resolve, which are then output and displayed on the monitor to be read by the connected probe. Once the profile is complete, we can move to the Graph Options section and save the profile so we can use it to build our 3D calibration LUT. Once we save this profile, we can click on the LUT Tools button in ColourSpace to open the LUT Generation dialog window. From here, we'll select our target color space, Rec 709, in the source area, and we will select the profile we just performed in the destination area. Finally, we'll give the LUT a name, in this case, User 1, and then we will press Create. This will build our 3D calibration LUT. Once complete, we can click on the Space Management button. Click on Working LUTs to find the 3D LUT we just created, then export that LUT in the FSI 17.cfe format required by the display. We'll be saving this LUT to the User 1 memory position, so we'll ensure it is called user1.cfe, then click Export. Now we plug the USB update cable between computer and monitor and copy and paste this LUT file to the display. Lastly, we'll go to the Color Management menu on the monitor and select Update LUT to save the LUT to the display permanently. Then we'll return the Bypass LUT option back to None so that all LUTs become active. And then from the ColourSpace option on the monitor, we'll select the User 1 memory position we just saved to. The LUT we just created will now be the active calibration LUT used on the monitor. Once the calibration is complete, we can return to ColourSpace to verify our result. We'll do this from the Profiling window. We'll return to Display Characterization, and this time we'll select Memory Colors and Secondaries to get a quick overview of the display's calibration result. Once this profile is complete, we can review the chromaticity, gamma, and RGB balance charts to see that our calibration result is quite good. We can also take a look at the delta E for grayscale, and as you see, the deviations are quite low. Then, looking at the delta E distribution chart, what we hope to find is something that is very left-weighted, indicating a very high percentage of very low DE values, which we do have as desired. We can also use this innovative volumetric view to see that our calibration results are quite good, with all measured points showing as green, indicating a very low DE measurement per reading. We hope this has been a helpful preliminary overview of using ColourSpace to calibrate an FSI monitor. If you have additional questions about calibration, please reach out to our support department at support@flandersscientific.com.